Hello everyone, welcome to our YouTube channel, and in today's video we will be knowing about the introduction to embedded systems. An embedded system is one that has computer hardware with software embedded in it as one of its important components. So here is a diagram which shows the structure of embedded system. Components of embedded system. There are three main components of embedded system. It has a hardware, it has main application software, it has a real-time operating system, that is RTOS. The hardware includes processor, timers, interrupt controllers, I/O devices, memory, ports, etc. The main application software which may perform concurrently the series of tasks or multiple tasks. RTOS is defined the way the system works, which supervises the application software. It sets the rule during the execution of the application program. A small-scale embedded system may not need an RTOS. So here is the diagram which shows the embedded system hardware. Embedded system constraints. An embedded system is a software designed to keep in view three constraints: available system memory, available processor speed, the need to limit the power dissipation. When running the system continuously in cycles of wait for events run, stop and wake up. The embedded system is classified into three categories: small scale embedded system, medium scale embedded system, and sophisticated embedded systems. Small scale embedded system is a single 8-bit or a 16-bit microcontroller. Little hardware and software complexity is included. They may even be battery operated. Usually C language is used for developing these systems. These systems need to limit power dissipation when system is running continuously. Here are some of the applications of embedded systems. Embedded systems is used in household applications, video games, calculators, medical equipment, electrical and electronic motor controllers, cellular telephones, digital music instruments, etc. Here is a diagram that shows what is an embedded system. Here are some of the other examples of embedded systems. Here are some day-to-day applications of embedded systems. So now we'll see what is the difference between microprocessor and microcontroller. Microprocessor has higher clock speed than microcontroller. Microprocessor is expensive and microcontroller is cheap. It is used for general purpose and microcontroller is used for single purpose. Microprocessor requires very high power. Microcontroller requires very low power. Now we'll see what is the difference between hardware and von Neumann. Hardware control unit for two buses is more complicated and expensive. In von Neumann, one bus is simpler for the control unit design. The code is executed in parallel in hardware and the code is executed serially and takes more clock cycles in von Neumann. Hardware average computation speed is high and in von Neumann average computation speed is low. Now we'll see what is the difference between CISC and RISC architecture. CISC is complex instruction set computer and RISC is reduced instruction set computer. In CISC, more number of instructions is used and in RISC, less number of instructions is used. In CISC, programming is easy and in RISC, programming is difficult. In CISC, no pipeline or less pipeline is used and in RISC is highly pipelined. Complex in design and in RISC, the design is very simple. In CISC, the small code sizes are used, and in RISC, large code sizes are used. And now we will see what is the difference between the static RAM and the dynamic RAM. The static RAM is made up of flip-flops and the dynamic RAM is made from capacitors. The static RAM is high in cost and the dynamic RAM is low in cost. In static RAM, the power used is high, and in dynamic RAM, low power is used. The static RAM is used in cache memory and the dynamic RAM is used in main memory. So here we conclude our video. Thank you for watching. I hope you enjoyed the video.